once the state table is constructed, now we can derive a state equation. So this is the state table we constructed from state diagram in the previous slide. Then how to construct a state equation is as follows. What this table says is that when currently flip-flop AB has those values with the input of those ones. So these are current values on the flip-flop, and then on next clock tick flip-flop value will change to those with a output like that. So remember, in D flip-flop, D input and Q output, the output of the flip-flop will be whatever is currently present on D. On next clock tick, whatever is on D will appear on Q. That's a D flip-flop. So with what this table says is that these are the expected value of flip-flop A and B. Flip-flop A and B should have those values on next clock tick. Then to have those values, then whatever those values should be on D input now, then on next clock tick those value will appear. So these are the ones to be fed into D input. So if we say function, that's this part is some function in terms of present state A and present state B and then X, then this is a function that this function should be connected to D input. Then on next clock tick, the function output will appear on Q. Similarly, this is another function. Let's say it function G with the present state A, B, and X. Then on next clock tick, this will appear. So at this moment, the function F should be on D input of a flip-flop A. Function G should be on input D of a B flip-flop. That is something we need to do. So what is then function F in terms of those? That is given as a kind of a truth table. So function F, we have all possible input cases, and then the function F becomes a 1 only at those cases. And another function for this one is when these are possible inputs, then this function becomes a 1 only at this case. So if we take a look this information in terms of that function only, so this is a function F function G, then this is a more like a truth table part. So if we focus on that aspects only, this is more like a truth table. Once we have a truth table, we can derive a function expression using K-map. So for this one is a t of 1 on next clock tick. So a t of 1 function is based on those 3 inputs. So we can derive a K-map for that. So in this K-map, we have A input and then B and X, a 3 variable K-map, 0, 0, 0, 1, 1, 1, 1, 0. And then this function is a 0, 0, 0, 1. So 0, 0, and 0, 1, this is the order. And then 0, 1, 0, 1, 0, 1, and then 0, 1. That is the order. Then function a t of 1 is we can do a simplification. We have prime implicants, we have prime implicants, both of them are essential. So this prime implicant expression is a does not change, but b changes and x does not change. This one expression is a changes, b does not change, x does not change. So ax or bx is a over t plus 1. So that is the one. So that is this a function result based on those inputs. So another function is b t over 1 is we can draw K-map for that, a and then bx in present state. Then output should be 0, 1, 0, 1. So 0, 1, 0, 1, then 0 0 0 0 0 0 0 0. So we have this assignment is a prime implicant, also essential. Expression for this one is a does not change with a not, b changes, and x does not change. So that's the one. And then y we do very similarly. So we construct k-map for y, a and then bx, and then y is 0 0 1 0 0 0 1 0 1 0 1 0 1 0 1 0. So prime implicants and then prime implicant. So 0 0 0 1 1 1 1 0. So this prime implicant expression is a bx naught, and this expression is a and then x naught does not change. So this is the expression for y. So we have derived the state equation out of the state table. So once we have state equation, now we can draw logic diagram. A and B, those are flip-flops. So we have two flip-flops, D flip-flops here. So D input, Q output, and then Q not output is there. And let's label this output as A, and this is a B flip-flop. Then input to A flip-flop is AX BX. So if we have X input here, OR gate first, then we have a 2 AND gate, then X input here, and then another X input here. Then for those 2 AND gates are provided, that's this one, and then this one gets from A, this one gets from B there. And then for B flip-flop, input is A not X, so A not is here, inversion of A not, AND gate, and then X, we get X from here. And then for Y, what you get is A or B and X naught. So we have let's make X naught here. So we have a NOT gate, X naught is there, and X naught, and then A or B is ANDed together. So A or B is ANDed together. So here we get A is here, so we take this out as A, and then B is here, so this line is a B, so let's take this line and connect it to here. So that's a logic diagram for this state equation.